Hello everyone, welcome to another webinar from Toradex. The topic today is next generation industrial PCs, AI-ready ARM-powered x86-Free. I am Lucas, I am Product Marketing Manager here at Toradex, and together with me I have Simon. Hi Simon.
Hi Lucas, hi everyone.
Simon is one of Toradex's product managers here. Just before we start, a few organizational points. So there is a chat window there. Feel free to use it in case you have any technical issues. Our team is monitoring it and they will assist you. Also, at the end, we will have a Q&A session. So in case you have any questions, please put them in the chat window and then we will pick them up at the end. And last point, this is being recorded and it will be made available for later on-demand viewing in case you want to pick up anything that we discuss here today. So with that, we are ready to dive into the contents. I'll start with just some corporate slides from Toradex. So Toradex historically has been a manufacturer vendor of systems on module, but in the meantime, we evolved to offer much more than just systems on module. Now we do embedded solutions. So I really like this exploded view there with the systems on module right on the center. Today we go much deeper on the stack, so deeper than the system on module. We do single board computers, we do volume-ready carrier boards. This can be customized depending on your needs, meaning that we can like switch interfaces, add interfaces, any sort of single board computer need that you might have, we can customize, maintain, manufacture for you. Even deeper on the stack, we do complete solutions, meaning we do industrial enclosures, we can do like display integration, camera integration, any external accessories you might need. We can integrate all of that for you here in-house with the same quality and that you see on our systems on module with the same engineers. And going up the stack, of course, we also have our famous Linux offering, very high quality, very reliable Linux offering. There are our Yocto meta layers that you can use for embedded Linux. There's also Torizon OS, our Linux-based OS that's meant to make your life much easier during development. We have a whole bunch of tooling to help you in development for your application to, in case you don't want to use Yocto as well. It's very easy to use. And Torizon OS also has the very neat benefit of connecting with the Torizon Cloud, which is the last layer of the stack there. Torizon Cloud is our connected services offering. It allows you to very easily manage your devices in the field. It offers OTA updates, over-the-air updates, right? It offers remote access, device monitoring for you to monitor the health of your fleet, for remote troubleshooting, all of that built from the ground up with security in mind so that you can easily comply with cybersecurity regulations like the EU Cyber Resilience Act, for example, and to make your life easier, to make you go to market faster, and to lower your total cost of ownership. So Toradex, historically known for its quality, its reliability, fits very nicely into some of the some specific verticals, the ones that we list here. So healthcare, industrial automation, robotics, transportation, energy, smart cities, and also a whole bunch of AI and computer vision applications. So because of our known quality of products, of services, we fit very nice in these mission critical verticals. And talking about volumes, we can go from lower volumes like 500 pieces per year for your standard SOM or SBC offering, up to hundreds of thousands of pieces per year, especially if you adopt our full stack solution with like customizable single board computers, our complete solutions, customization services, Torizon Clouds, then you really reap all of the benefits that Toradex provides. So this is our SOM portfolio, our systems on module. We have 5 different families, and members of the same family are pin-to-pin compatible, so you can scale up or down in performance depending on the needs of your end product. The Aquila on top there, it's our highest performing family with the Aquila AM69 and Aquila AM69. They will be most of the topic for today's webinar, so I'll leave most of the discussion for Simon. We also have Verdin, scaling from the Verdin AM62 up until the Verdin AM-X95 in performance. So it's a wide range of performance. It's a very nice fit for many different applications, from like higher powered robotics to low power, battery powered applications. Verdin is a very nice, very easy to use, very low cost solution. We also recently introduced the Smart family. So for customers that need the Smart form factor for one reason or another, now they can also benefit from all of the Toradex value that I was just talking about, the quality, the reliability, our supports, Torizon, our software offerings, our customization services. People that need to use Smart also can now leverage all of that. And of course, we also have our slightly older families, so Colibri and Apalis. They've been with us for 20 years or more, and they're still kicking strong. We still support them, and we will still keep supporting them for many years. Just goes to show how the longevity of Toradex's products, how wide we have been supported our products, our older products. And with that, I pass it off to Simon to show how all of that relates in this very nice performance price chart here. So Simon, with you, thanks.
Thank you very much, Lucas, for the great introduction. Hi, everyone. So what you see here on the screen, as Lucas said, is a chart showing the performance and the price, basically, of all of the system of modules we have today. So the y-axis is the performance, the x is the price. And what we are primarily going to talk about today is the Aquila family that you'll find in the top right section of this chart, meaning that these are the most performant system of modules of ours as of today. And of course, the price of these is also matching the performance level. One important note, and I think this I would like to emphasize because the chart does not really show it, is that if you compare these offerings and you try to check where do you get the most performance for the unit of currency, actually Aquila is the best there. So not only the most performant, but the best value for the money as well. And with that, we can move on to the next slides. And we will start with a poll here. So we just would like to understand a little bit better your context, your current situation. If you have a product in mind or if you are curious about what we have to say here. So please answer the question the way you feel it suits you best. Are you considering migrating from x86 solutions, maybe like using Intel Atom single board computers? Are you considering migrating from NVIDIA-based solutions, or just looking for more performance? Or you are curious, interested what's happening in this very exciting segment of the industry? And I'm seeing the responses incoming here live. And I'm seeing a good distribution overall. I think there is a tendency for x86 migration. It's not surprising, but great to see. I'm also seeing quite some of you interested in a higher CPU performance, which we will be able to address as you see it. And there is a healthy portion of you who are curious, looking around and trying to see what's going on. So I think with that, we can move back to the slide deck. So first, I would like to talk a little bit about this high performance shift, which is not specific to our industry. You can see it basically everywhere. And we wanted to tear it down a bit and look into what's happening, why is it happening, and what does it mean for us, what does it mean for you. So the first is, of course, the business needs. These are changing, there are new use cases emerging. There is demand and need in the market for applications which are requiring more and more performance, more and more specialization, new accelerators, etc. We can't start, continue, and finish this webinar without talking about AI and machine learning, the technology and the trend being very significant, not only in our industry, but everywhere, basically. and also what is connected with it, computer and machine vision. So these are there. Many new applications are leveraging these technologies, and this is basically redefining not only our product portfolio, but our lives altogether. Looking further, we also just see that in general, the computational performance has been increasing in the past, is increasing today, and most probably is going to increase in the future as well. So this is continuously opening up new use cases or pushing use cases in the domain of feasibility, which were maybe not possible before. And what all of this does, it is also increasing complexity. If you are looking at the higher end offerings, you look at the system and chips, you look at what does it take to actually take and integrate these and bring them up and put into sustainable, effective production, the complexity is also growing. While the pace of the world continues to accelerate, also the markets. So we would like to be faster, we would like to be there earlier, and there is a need created around solving that complexity and developing and releasing easier to use solutions. So you can actually concentrate on your end application, and you can put most of your knowledge and experience into where you truly make the difference. So this is creating an opportunity for you and us as well to take these complex technologies and make it into a package which is usable and enables a faster time to market.
Yeah, specifically on that, Simon, I also wanted to complement the complexity growth. I think it's not only on the hardware side, but also on the software side, right? So as we shift towards these higher demanding use cases, these high performance use cases, we also see the software stacks moving away from like low level programming to more like NPU programming, AI programming with all of the frameworks that we all know. So making these solutions or making this more accessible to our customers happens not only on the hardware layer with like SOMs and offering more like turnkey solutions and all of that, but also on the software layer, making Linux very easy to use, making sure that all of these frameworks are running from day zero, accelerated and all of that, so that our customers can also leverage all of the benefits then on the software side as well.
Yeah, absolutely. And there are also other trends and events ongoing which further drive and increase complexity, like think security there, or safety could be another topic. All these come together, and that's what we are trying to solve for simplicity, reliability, and ease of use. On this slide, we will have a look at the use cases which are in the background on a higher level. 2 years ago, when we were defining the Aquila family, these were the outcome of a product discovery, which was done with your help. Actually, we got a lot of customer feedback and customer inputs, and even the first ideas for doing such products were actually coming from customers. So I'm really grateful for that close connection, that tight link there, which allows us to pick up what's important or what is making a difference in the market. What you see on the screen now is already a refined list of use cases. So this is more than the initial concept. This is augmented by all the market and sales information we have today. So this is also based on real customers we are working with. And so going through the list, you see vehicles, drones, so automated and autonomous or guided vehicles. Examples range from agriculture through surveillance to defense. The next big category is robots, stationary or mobile. One important part there is in healthcare, lots of surgical applications requiring vision and diagnostics, but logistics, warehousing, transportation of goods, or manufacturing support are also among the use cases. Cameras and surveillance systems, be it about security or be it about a very interesting case of sports tracker solutions, but again also going in the defense direction. data acquisition and communication solutions, high throughput connectivity products, cryptographic products, also mentioning defense here, and test and measurement equipment also is a very relevant part there, used in manufacturing, but also in maintenance, predictive maintenance. And there are some other cases, but here we wanted to just pick out the mainstream ones we are seeing at the moment. These are quite different, but there are a few things common. All of these depend on reliable, real-time, and high-performance compute, be it about AI and machine learning, or be it about vision, or be it about just raw CPU performance.
Interesting to get your view on the near future, Simon. How do you think, like, given this shift for higher and higher performance, this demand for higher AI, computer vision, how do you think what do you think we're going to see here on use cases on the next 5 to 10 years? I'm thinking like collaborative robots, all built on top of these building blocks that you are showing here.
It's a very interesting question, Lucas. So you could also look at these as elementary building blocks of more complex use cases, and the collaborative robots you mentioned is a very good one. What we also expect is that with AI and vision spreading and appearing in applications where it was not before, and things getting smaller and cheaper over time, probably there is a broadening range of use cases as well. New ones appearing here, which from tomorrow on can leverage vision and the machine learning capabilities. And where it's, to me personally, getting most exciting is really the collaborative robots and all the other stuff which we probably do not yet see today, because this is also how markets and innovation works. There will be new, very exciting cases which will disrupt and redefine whole industries. Would be happy to see those, but maybe in 5 years we can say more. So here we go with a poll again. And here we are asking you about your primary use case. Is it around AI machine learning? Is it computer, machine vision, automated or autonomous air or ground vehicles, defense, or something different? So please just give us your feedback here. I'm already seeing the inbound responses on the screen. There is a healthy portion of computer machine vision, roughly 1/4 here. AI machine learning, more as a generic term, is in a similar range. I see defense, 10%. That's interesting. And there is also some none of the above, which I also expect partially to be us not feature all the use cases here, but also having some of you who is more curious and looking around what's available and what's coming in the future. Continuing with processing, and maybe starting here from the past and then looking at the present and trying to have a look at the future too. So if in the past we had larger amount of data to be processed, typically we had two options, one of them sending to the cloud, processing there, or we could also leverage x86 devices for local processing. Here, I mean, many of us are familiar with the Intel Atom-based SBCs, which personally I also used in the past in a different company, in a different position, as a compromise or a workaround after trying with an ARM-based solution for a computer vision application, which was quite hungry on performance. Did not work with one ARM devices. It worked with two. So imagine the same device stacked atop of each other, one doing point cloud processing, the other one doing some higher level data aggregation and communication. In the end was resolved into a single device, an x86 device. That's what back then was able to provide the performance we needed. But this was like 6-7+ years ago. and it would go different today, and how and why, that we will see together later. So here it's a continuation of the previous slide. On the left side, you see basically the past processing in the cloud. On the right side, you see the ongoing shift, present and the future, processing on the edge. And there are a couple of aspects along which we are looking at both and try to see the differences, the pros and cons. So one thing is latency. If you want to process in the cloud, you obviously need to transfer your data, wait for the processing to happen, and wait until you get it back on the edge. So this introduces some delay. It delays the decision-making process too, and in some cases it can introduce safety risks. Looking at the cost side, which is very important for all of us, at the edge with local processing and no high bandwidth connectivity needs, the cost could be reduced. Cloud typically is scalable, but comes at the cost. And we also need to pay for all the infrastructure which is involved, and this needs to be resilient, this needs to be reliable, with great availability, and that typically will cost money, which is visible. Looking at the dependency for the networking capabilities, if the processing is happening on the edge, then the edge devices and the software running on them can have greater increased autonomy. And we already talked about the round trip delays, which are also eliminated. There is an interesting aspect with data privacy and security. So local processing is beneficial for increased privacy and can help in certain cases with regulatory compliance. On the other hand, for cloud processing, the data needs to be protected in transfer, at rest as well. And there are always some risks involved here. I'm not trying or willing to say here that the local processing does not have its own risks, but these are different in our view. When it comes to scalability, scaling on the cloud side, we look at as being more expensive than scaling the number of your edge devices, which are oftentimes more directly connected to the local need you are solving. So this we see processing on the edge as a scalable way where you can take care of the scale up in a decentralized way without too much dependency on the cloud and without the connected costs as well. This is not a full overview, but should give you an idea about how are we comparing these two. On the next slide, we are going one step closer to the main topic of today. And here we are looking at x86 and we are looking at ARM, or more specifically x86 and ARM-based devices, and some of the constraints or pros and cons of these approaches. And I will start from x86, which you see on the left in blue. So one very important topic which we need to mention here is Windows support. So the x86 based devices traditionally and also today are offering Windows support, compatibility with not only the operating system, but also lots of applications and frameworks, maybe mentioning .NET here. And many of the end applications are leveraging this ecosystem. So this is a very important differentiation of the x86 ecosystem. Traditionally also for compute intensive applications, the performance which was needed was provided more by the x86 based devices. And if we look or turn away for a moment from the traditional embedded industrial space, we still see that if it's about just gross performance, server grade performance, we can get that on x86. And ARM is catching up, and there are more and more performant devices coming, also for server-side applications. But I think if power and money are not no obstacle, then x86 still allows you to get to higher performance levels. The ecosystem, which on x86 is broad and stable. Think about not only Windows, but think about Linux and all the open source software available. So it's really a vast ecosystem which enables you to focus on your application and deliver relatively quickly. And with that, we are moving over to the ARM side and look at different aspects there. So let's talk about value and price. So if you look at an ARM-based solution, typically compared to x86, you can get similar performance at a reduced price or much better performance at a comparable price. Here, you will traditionally also find all the industrial I/Os you are expecting, be it analog or digital, all the low-speed interfaces, UART, SCAN, SPI, I2C, ADC, many more. One important aspect is that on the ARM side, we are seeing a very significant and continuous increase of performance. The architecture and the implementations have still a lot of headroom. You will see it here when you look at the concrete products. Modern compute cores are continuously being developed. We see a lot of different purpose-specific accelerators, be it about AI or be it about vision. So this is still a rapidly growing and innovative field where we see tremendous performance increases in the past couple of years. The ecosystem itself is also growing, and it does it rapidly. I think on the hardware side, this was already traditionally a relatively broad ecosystem with vendors, with boards, with SOMs, with carrier boards, SBCs, accessories. But the growth we also see on the software offering side, operating systems, distributions, real-time reach, including support for a growing number of peripherals, cameras, displays. So this part is also growing really rapidly. And then mentioning safety here, functional safety and real-time, these are specifically areas and needs which could be addressed very nicely on the ARM ecosystem and which are very important for some mission critical applications. I would also like to mention power efficiency. Oftentimes we see the need for fanless systems with high IP protection grades, IP67 plus, where there is no room for slots. Fans are not ideal, like sealed enclosures. And this is where the power efficiency of the ARM implementations comes in. Similar to the value and price comparison, if you look here, you take an x86 and an ARM-based device. If you set the performance equal, then the ARM-based device will consume significantly less power. If you set the same power consumption for both, then you will get much more performance out from the ARM-based device for the same power. I think there are a lot of interesting discussions about, is this really the architecture differences, or is this really the different implementations? We'll be curious to see where x86 is going. There are indications that also the challenge is understood there, and it will be probably another exciting thing to watch in the coming couple of years, 3, 5 years, 10 years. Where do we end up?
Yeah, I think here, like, we talk mostly industrial, right? But also we see the shift, of course, on the consumer side with like Windows on ARM, Apple's new silicon, ARM-based new silicon. So I think as ARM's performance grows, Windows support coming to ARM, all of these lines get a bit blurrier, right? And that's where ARM's advantages really shine, right? Like the power efficiency, the real time, the ecosystem. So yeah, here we talk mostly industrial, but also, of course, this trend happens also on other verticals as well.
Yeah, that's a very good comment in my opinion. And looking around just in our offices, I see a growing number of people actually doing their daily work on ARM-based devices, and I think this probably also, it starts in consumer, at least on the higher performance side, but all this innovation is trickling down, and we get also access in the industrial application. So I think it's a very exciting time to be in and to deal with products. With that, we can turn our attention towards the Aquila family, which is one of the main topics for this webinar. So what is Aquila? Aquila is a family of pin-to-pin compatible system of modules. Pin-to-pin compatibility here meaning that if you take one Aquila SOM, like the one I'm having here in my hand, and you design your product around that, then later you are able to select another Aquila SOM, maybe featuring a chip from a different vendor, having different key components, maybe more RAM, less RAM, tweaked to your scalability needs, and you can swap this out while leaving the rest of your design unchanged. So this is providing you with lots of scalability with regard to your end product. What also is important with Aquila, it's built around high performance. When I say high performance, we primarily mean AI machine learning performance, vision performance, and CPU performance. Aquila SOMs are using a single 400 pins, high performance, robust, reliable board-to-board connector, which I can maybe show you here as well, live on the screen. So you see it's a single connector. This provides for a very robust, reliable, vibration-proof installation, which is another important point of Aquila. So even though this is high performance and bleeding edge in terms of performance, there is no compromise on robustness and reliability. This is ready for industrial applications and is going to perform in other harsh environments. So it's not that it's capable, but you need to take some compromise on the reliability or the lifetime in the field. It's not that you cannot run this at 75 degrees ambient temperature. All of that is happening. Aquila also offers a modern and future-proof interface and feature set. You will see it on the upcoming slides here, just hinting at it. Display port, multiple PCI Express instances, each and every one of them supporting multiple lanes, up to 10 gigabits Ethernet. These are just some of the few. Full industrial temperature range support from -40 degrees Celsius up to +85 degrees Celsius. We have other temperature ranges too, but this is the broadest we are offering. And also we are launching Wi-Fi 6E and 7 capabilities, first time on the Aquila form factor. Wireless for us is typically optional. If you need Wi-Fi or Bluetooth, then we have configurations which will give you exactly that. So here is an overview of the actual interface set of Aquila. You see it's divided into 3 categories or groups. There is a so-called always compatible, a reserved, and a module specific. This is something which we inherited from a very successful other product family of ours, that's the Wordin. This is where we had this concept first. So interfaces and features which you see in the always compatible class are basically present and will be present on each and every Aquila SOM. What this means to you is that if you are using these features, you are able to freely swap out your current Aquila SOM to any other Aquila SOM being there today or coming in the future. So that gives you a lot of scalability and flexibility. On the reserved interfaces, these are present and will be present on most of the Aquila SOMs. There could be exceptions. For example, maybe there will be a SOM which only has one MIPI-CSI interface and not 2 as allowed by the specification. But in that case, the implementation will always be electrically compatible. So you can always swap out still. You're not risking any damage, any issues, but you need to watch out that if you need 2 IPCSIs, like in the example, you need to make sure that the replacement product has 2 of them too. Looking at the module specific, this is where the unique features of the system of modules happen. This is a healthy number of pins allocated to these unique features. If you use these, then you get unique value, but this may also prevent you from easily migrating to another SOM, because of course each and every SOM will have its unique capabilities, and between the SOMs these are not guaranteed to be compatible, not even electrically, even though we try to do our best there. Shout out to our engineers who are always striving for the best outcomes. But yeah, if you want to use module specific features, it probably pays out to be a bit more proactive and look around how would it work on other SOMs. And here just highlighting a couple of interesting interfaces. So you see we have 2 IPCSI instances here, all of them quad lane, typically supporting virtual channels too, so together capable of receiving 12, sometimes up to 16 camera streams. Imagine what you could do with all of that. The DisplayPort interface, then we have SGMII or USXGMII, so basically from the parallel media independent interfaces moving into the faster serialized world. This is also the interface which allows up to 10 gigabits Ethernet connectivity, with the 5 being placed on carrier boards. But of course 5 gigabits, 2.5 gigabits and 1 gigabit options are also available depending on the particular SOM you are looking at. We also have 2 USB 3 super speed ports, one with dual role capability, the other one a host port, and we already mentioned before the multiple PCI Express instances, which we allocate quite some lanes to, so there is scalability up to 4 lanes each, which is a very interesting capability enabling quite some use cases. On this slide, you get an overview of the Aquila AM69, which I already showed you before. Maybe I will repeat that. You see the AM69 chip here. You see 4 RAM ICs in close proximity. You see the power delivery network there. It's quite some inductors, and you also see here a wireless module, which is delivering that Wi-Fi 7 capability we talked about. On the bottom side, you see an eMMC device, and you also see the 400 pins connector, which we've been talking about before. So after getting into closer contact with the product itself, this is Toradex's highest performing SOM as of today. This is mapping into a complete new territory for us. Just to give some scale to that, this is 3 times the performance of our previous flagship product, which is the Aquila MX8 Quad Max. The Aquila AM69 is ideal for robotics, for AI, for machine and computer vision applications, but also for real-time control, where you need to deal with a large amount of data, process that, and react on time to drive actuators or deal with the rest of the system. As said before, this is based on the TI AM69 processor, so from Texas Instruments, which is featuring 8 times Cortex A72 cores. We also have 4 Euler accelerators here, together delivering up to 32 TOPS of AI performance, which is unprecedented in the SOM world, as far as I know. You've seen the 4 RAM chips there. So this particular module, which I'm having here, is equipped with 32 gigabytes of RAM. And you see it really kind of fits in the palm of my hand, and it feels strong, it feels sturdy, and the performance just encapsulated here is truly amazing. To give you another perspective, I will be showing to you a 12 by 12 centimeter carrier board, I mean X and Y dimensions, mechanical dimensions. This will be featured later in the webinar. And why I'm showing this to you is just to give an idea of how small the landed size of the SOM gets on this 12 by 12 centimeter carrier board. This is really interesting, and there is a lot of work flowing into this. Maybe I need to make another shout out to our designers and engineers who go and take in all these ideas of product, and they come out with all these amazing products at the end. So going back to the slide, up to 10 gigabits Ethernet, that was mentioned before. And another interesting one, with this product, we can achieve 2 times 4 lanes PCI Express capability, meaning suitable for very high-speed storage like NVMe drives. But we would really need to also look hard to find accelerators which would need more bandwidth than what we can provide here. There are some further interesting highlights here. 6 times Ethernet ports. We can drive 3 independent displays. Highest resolution can be up to 8K. We can deal with 12 cameras via the IPCs instances. And this was very hardware oriented, but I would like to mention our well-known Yocto BSP layers. Would like to also mention our platform and operating system offering Torizon. Some of you may be familiar with Toradex Easy Installer, which makes it easy, straightforward, and fast to provision our products with the help of a graphical interface. So there is also a lot of software incorporated here. We are talking about hardware features, but what you get is an end-to-end package with hardware, software, and services in the end. There is another very interesting product. This is called the Aquila AM69 This is a product we are currently working on, bringing forward the already visible success of NXP's AM69 system on chip to the Aquila family and the form factor. So this is a SOM which is going to be pin compatible with the Aquila AM69. From a family perspective, compared to the AM69, which is a very high-end, very high-performance solution, this is going to establish the lower end of the Aquila family. Just with a reminder that Aquila is meant to be high performance by default. So what I'm saying here is that the AM69 is also a high performance chip compared to what's available in the market today. But in the context of the very high performance Aquila family, this is still going to be an entry-level offering here. And with that, we are reducing the barrier of entry, we are reducing the price, and we are providing a scalable way to tap into the Aquila ecosystem. If you don't need all that performance right today, you just want to have a solution which you can take and use and have that scalability towards the high performance products for the future. So looking a little bit at the details, here we have an i.MX95 processor from NXP with up to 6 Cortex A55 cores. We also have a dual Cortex M here for real-time applications. We have a modern NPU, which is doubling the performance of the i.MX8M Plus, which some of you or most of you are actually familiar with. It contains enhancements for functional safety use cases, and it also comes with the exact same software stack as we described before. And on later slides, there will be some more information on availability and roadmaps, so I will leave that for later. And now, probably the time has come to reach out for this product, which I showed to you before. I mean, you see it on the screen as well. So this is Clover. This is the first production intended carrier board in the Aquila family. And why am I saying that? We have another carrier board here. This is also an Aquila carrier board, but this is a development intended board. So you see that this is where the SOM plugs in. You see a lot of jumpers here, headers, connectors, level shifters. So this is a board which is meant to be used in evaluation and development, prototyping. Everything is rooted out, broken out, everything is reconfigurable. You can use it for creating proof of concepts with a lot of extra level shifters, buttons, switches. So this is really meant to be played around with and used on your desk to get familiar with the products and build something out of it. This one, on the other hand, the Clover, is designed for manufacturability and testability. It's optimized for cost and high volume production. So this is a board which still contains most of the standard features of Aquila. So without much compromises, you can get into a compact nano ITX form factor, 120 by 120 millimeters, and implement your product based on this, and basically get to the market faster. So that's the differentiation between the carrier boards we are offering. There are the development intended ones, and then there are these production intended ones, which are optimized for production. And of course, as a volume product from us, this is under full PCN commitment with longevity that is applicable to all the SOMs we are talking about here. So 10 plus years availability on everything, and product changes under standard PCN implementation. So with last time buy, last time ship, bringing quite some peace of mind when it comes to supply chain. And this is getting more and more important just again. For connectivity highlights, we have 2 gigabit Ethernet ports here. We have 2 M.2 slots for high-speed extension and expansion. We have a 40-pin extension header providing access to some GPIOs and analog and digital low-speed interfaces. Can mention ADCs, PWMs, I2C, SPI, and etc. What I really like, and what based on the feedback of our customers is really helpful, that these designs, and this is not specific to the Clover here, it's basically all of our current carrier boards, these are open source and available free of charge. So what this means, you can download from our websites the Altium files, the schematics, bill of materials, and all of this is available. So you can just take it and manufacture it if you would like to, or you can take it or customize it. You can remove features, you can add features, you can put it into an enclosure. So this gives you actually all the creative freedom to create the product which you need to make you successful. And talking a bit more on customization, I think this is nicely bridging to the next slide, where we also put this into an offering for you. So while it's an option that you take the product and customize it, we are also happy to help with that, and we have the capabilities for this internally, including manufacturing as well. So you should probably look at this as a menu list. Everything is optional, nothing is mandatory. You can select the options you need. So for example, you could come to us and you could say, I like the Clover, but I don't like that it's missing this and that feature. Or I like Clover, but for me, it's a bit more too expensive and it's too big. We can take that in, we can remove features, add features, modify the product according to your need. We can take it to the next level by taking care of the electrical and thermal integration. We can design enclosures. We can do certifications on top of it, and we can take care of manufacturing and managing all of that and maintenance as well. So it's up to you. What would you like? Probably the only reasonable call to action I could give to you is that if you feel that there is any area which you would like to offload to us, just remember this, that this offering and service is available for you, and we are more than happy to contribute. So reach out to us if you have any such cases. And here on the bottom right, you just see an enclosed product on a DIN rail mounting. This is one of the examples, but there is a lot more of what we can do for you.
I wanted to reiterate here, Simon, one of the main goals of Clover and our customization services, our Toradex solutions offerings, is to first, of course, lower your cost of ownership by leaving a lot of the hard parts for Toradex's engineers to do, but maybe even more importantly, for you to go faster to the market. With Clover, or with our customizable single board computers and volume carrier boards, we have actual cases of customers going from start of development up until pilot run in less than 6 months, which is much faster than what we usually see in the industry. So this, in the end, is our end goal with all of these customization services, volume carrier boards offerings, and all of that.
That's a very good one, Lucas, and I think it very nicely maps to one of our key principles. So the way we look at it is that we as Toradex, we can only succeed if you are successful with your product out there and you are purchasing from us. And if you look at our websites, if you look at documentation, if you look at the services, if you look at the open source carrier board designs, if you look at the customization services, later you will see it with the software stack, all the simplification, the off-the-shelf things. These are all centered around accelerating your time to market and increasing your probability of succeeding out there, because that's the only way for us to be successful. Here, there is a very interesting demo. It is going to be in the form of a video. This was pre-recorded before. Before playing it, I just would like to give you a description of what's happening here. So you see an Aquila development board, which I showed you before. There is an Aquila AM69 SOM, which you don't see because it is featuring an active thermal solution on top of it. And you see a display with 4 cameras on top of it, which are not well visible, but they are there. And on the screen, you see 8 segments displaying 8 video streams. So what's happening here, these 4 cameras streaming or providing an image stream to the system. There are also 4 video files, which are treated as 4 additional image streams. So the AM69 SOM is doing parallel video decoding on these 8 video streams at 1080p at 30 frames per second. And then these streams are fed into 8 different machine learning models in parallel. And inferencing is running at a stable 30 frames per second. And the 8 streams which you see on the display are actually the outputs of that ongoing inferencing. The whole environment is a office or room setting with roughly 25 degrees Celsius temperature. And what you see is that the temperature of the system under that load, which was just described, is 40 degrees Celsius. You see also a power consumption of 30 watts. And what you can maybe see, there are some bars at the bottom of the screen which indicate the load experienced by the various IPs of the system on chip. And the numbers are not visible, but graphically probably you see that we are way below 50% load. I think averaging around 30% probably. So everything the system does here is using basically 30% of the product's capabilities, and there is a lot of room for more. This is an easily reproducible demo using some of TI's tooling. We have instructions on those, so if you would like to try it out yourself, you just need the products, and we are happy to provide our documentation and guide you through if you need any support there. And with that, I think the time has come to see the contents. And what I'm hoping for and assuming is that network bandwidth is not going to be a limitation, and you will be seeing the video the way we see it in its full smoothness without hiccup and just nicely running there. The next slide is a continuation a little bit of the previous one on AI benchmarks. So what is happening here? An image classification task is being run on the AM69 with an ImageNet dataset and various models. And what you see on the chart on the y-axis is the accuracy of the classification task. And on the X, you see the frame rate. Conclusion here, running accurately 60 plus, 80 plus %, depending on which model, and frame rates ranging from 30 FPS to several hundreds of frames per second. And there is an important catch, which I'm not sure, Lukas, if you want to cover.
So my comment here would be with regards to this benchmark being on models running on one core, right, of the NPU. Simon mentioned briefly before, the 32 TOPS NPU on the AM69 is split into 4 8 TOPS core. So the benchmarks results here that you see are for just one single model, and they run on one core. So the other 3 cores would be idle in this case, meaning that you can, for example, run 4 of the same models in parallel with no performance degradation. Like we showed at the demo, on the demo case, we had 8 models running on the 4 cores, so each core was handling two models. So that's a very nice point parallelization-wise when you talk about running inference at the edge.
That's great. There is a lot of headroom remaining, more power available for all the demanding applications out there. That's nice.
Absolutely.
I think there is a logical question or topic emerging from all these demos and benchmarks. So how do we deal with models on these products? So Texas Instruments offers a suite of software oriented on deep learning. And the main target or goal there is ease of use and great developer experience. Of course, it's in everyone's interest to facilitate migrating your models to these products. So that's what is being tried to be resolved here. So what all of this enables you to do is evaluating and tuning a wide range of models, compiling and optimizing them for the AM69, and then run these on the product in an NPU accelerated manner. But this is still focusing on predefined available models. And probably you are more curious about, okay, but I have a model maybe used in another ecosystem, which was maybe very good for initial prototyping and had all the power and all the performance. And maybe it was expensive, but good enough as long as this was in development. But now you are looking at scaling up. Now you need hundreds, thousands of devices out in the field, maybe in a harsh industrial environment, and maybe you also have pressure on the cost side. So that's where this how do I bring and port my model topic becomes very relevant. And this is where the TI software suite, which is called Edge AI Studio, is very helpful. So going through the flow, it starts with a first high-level check if the model can run on the TI device or not, and what are the achievable latencies there. An important remark here is that you do not necessarily need to have hardware to be able to pass this first stage. So if you don't have the hardware, then the model analyzer tool or service can also be used here to give you that initial idea. In the next steps, exhaustive accuracy and performance benchmarks and deployment to the device are also enabled and facilitated by the tooling available. And on the bottom right of the slide, you just get an overview of how this flow is working with Edge AI Studio. So on the selection side, you can take models from the model zoo, or you can bring your own model and data. Then the training and refinement stage is supported by different tools, part of the Edge AI Studio. In the evaluation stage, you can use the model analyzer, as said before. You can do all the benchmarking, and you can do the deployment to the devices as well. This is done by the Edge AI SDK. Now, if you remember the demo, that was actually using the same ecosystem, and you've seen that the camera and the display handling was also a part of that. So actually, our application engineers did not need to develop this from the scratch. We heavily reused what was available from TI, and this is actually the same path you can follow on this one. This is continues to be developed and improved with new features, and we see very clear indications, not from Texas Instruments only, but also from NXP and from other very interesting vendors we may be talking to, that there are heavy investments ongoing in this area to make it easy and make it attractive to you to actually bring over your models and get access to all the value and all the advantages these products can offer you. With that, we are now reaching a side-by-side comparison. So we are taking an Aquila AM69 and we are also taking an x86 solution. We are picking here an Intel Atom quad-core product from 2021 or 2022, I believe. And we are comparing these along several important aspects. So starting from AI performance, the Aquila AM69 has the deep learning accelerator with the performance 32 TOPS, which we discussed before. That's missing on the competing solution. We have real-time capabilities, real-time cores, which are not present on the other solution. On the Aquila AM69, we are offering wireless connectivity, integrated high bandwidth Wi-Fi 7, 2x2 antenna configurations, 3 bands, so you can map out from the traditionally more occupied 2.4 and 5 gigahertz bands and get access to 6 gigahertz. This is not included on the competing solution. AM69 gives you all the traditional industrial IOs, which we discussed before. You get some of it on the x86 solution as well, but mostly limited to USB and PCIe. Some of the others require additional peripherals, which is contributing to your total cost of ownership. And then we reach the CPU performance. So these are passmark values. And you see that the Aquila AM69 is not only on par, but actually has like a 25-ish percent advantage compared to the x86 solution here. Then we can look at power consumption, which it looks equivalent at first sight, but you need to remember that in the Aquila AM69 case, we are including also the accelerators, which are not there on the other side. So this just reinforces the point which we made before, that for the same power, you actually get more compute with the ARM-based solution, or more specifically with the Aquila AM69 here. And there is a similar pattern happening on pricing. Just a warning, be aware that our pricing is a function of a lot of the product characteristics, varies greatly depending on the peripheral configuration, the RAM and flash capacity, the SOC variant, the temperature range, and also your volumes. It's different for 10,000 pieces per year or different for 1,000 pieces per year. So this is really just a benchmark price, not really indicative of what the final prices are, which depend on many things. First sight, you feel that these are okay, equivalent. But again, on the AM69, we are including all the accelerators, while on the competing solution, these are not included. You would need to purchase those as accelerator cards. similarly to a lot of IOs and peripherals, which you would need to further implement to get to an equivalent solution from a systems perspective. So there is a significant more value provided on the AM69 at a comparable cost. So just to summarize the top, we see the Aquila AM69 as a better fit if you have AI, machine learning, or vision applications, or if you require real-time capabilities, or if you have needs for functionally safe implementations. Use cases where we consider the AM69 and, for example, such Intel Atom solution to be equivalent are more these general compute applications where you have no specific needs for AI, machine learning, vision, or real-time or functional safety, but you are more looking for pure CPU performance. And that's how these compare to each other. It's a little bit different take here, just more along the use cases, comparing the same two solutions as before, trying to give each and every of these use cases to one or the other. So you see that the edge AI, compute vision, industrial automation, robotics use case goes to the Aquila AM69. We see that as a better fit. On the other hand, legacy Windows applications or software stack, which is tightly coupled to Windows and not compatible with anything else, we give to the x86 solution. Even if there is an interesting emerging trend, maybe for the future, we may also see better Windows support on some of the high-performance ARM offerings, but this is maybe more of a roadmap discussion. Raw CPU performance, you could put it in any of the directions. Both products are good there. Power efficiency, the advantage very, very clearly goes to the Aquila AM69. And with our environment being more and more important and energy costing and maybe being some uncertainties around energy on the long term, this we see as a topic which is more and more important for many of our customers. On the ecosystem side, depending on where you look, is it more hardware or software? Both of these have strengths and weaknesses, and depending on your particular use case, any of them can be a solution for you.
I wanted to also say, because it seems to me that the Aquila AM69 sits in a very specific intersection where on one side you have like high performance AI use cases, and on the other side you have like industrial needness, industrial readiness, be able to handle harsh environments and all of that. There are solutions already in the market for each one of these bubbles, right? But I do believe that where they intersect is where the Aquila AM69 shines the most, which is industrial applications, industrial cases in harsh environments where reliability is most critical, that also need that high performance, that need AI readiness, AI accelerators, and all of that. So that's my understanding from my take from these slides.
It's a very good one, and I think it maps back to the initial product discovery as well. We, with the help of our customers, got a lot of inputs, and we knew there is a market there, but it was hard to resolve it to a concrete size. And just all the use cases and all the customers and all the discussions happening just give a confirmation that this is an important part of the portfolio, which we are committed to growing further in the future. We touched a little bit on functional safety on the previous slides. So here, this one is asking you about if functional safety is relevant to your use case or not. Options being yes, preferably via the integrated capabilities of the SOM, or yes, preferably via external device, like in many cases it's an MCU, or no, it's not relevant. So please, if you have an opinion or a need, just give your response, and I will try to look at the responses coming in and just quickly summarize it to you. I'm seeing, yes, similar to a 50-50% split between yes, preferably via the integrated capabilities, and no. And this would also resonate or mirror my gut feeling based on the customer discussions we are having. There is a surprising number of cases where functional safety is relevant, and this of course means to us that in the spirit of accelerating time to market and making things easy, we also would like to just spend a little bit of time on how can you help on that topic. And this is going to be covered on the next slide here. So functional safety in general, we see a growing trend that regulators or regulatory bodies are pushing for higher levels of safety and also for better security. I can call out some specific verticals or use cases here: defense and aerospace. There is the obvious move from manned systems to unmanned systems, and these unmanned systems can be in the air, can be underwater, sometimes they are heavy. It's important that safe operations are guaranteed. I can also mention robotics here, where updates to some of the involved standards are happening and have been happening. ISO 10218 being one example. We have a nice webinar on that. So how could you reach compliance with this standard in robotics applications with Toradex and QNX offerings? Also mentioning healthcare here, medical devices, systems, or having functional safety requirements in the past were typically not really updated, but there are new processes required by the FDA. So this is changing too. And on this, there is again a nice webinar, which is recommended material if you would like to know more or if you are affected by this. So this one is cybersecurity and software updates in medical devices. So as you see, we are doing some steps to enhance our offering when it comes to functional safety as well. In our partner network, we have quite some partners who are also able to help you in specific areas or applications, areas of applications and verticals with domain-specific knowledge. And getting back a little bit to the Aquila AM69, I also would like to mention that the AM69 from Texas Instruments is an industrial system on chip, but it has a parent device, which is basically a superset device, also offering functional safety capabilities, and this is called the TDA4. There is a lot of variations of TDA4, and the naming is not always the most straightforward. We have a nice document on that on our website. If you are interested, you can have a look and get clarity on all this naming and which chip relates to which one. But long story short, the takeaway here is that our AM69 design is compatible with the TDA4 chip as well, or some variants of the TDA4 chip to be more specific. So via this pin compatibility in the framework of customization, we can actually build an Aquila TDA4 for you if that's what you need. And of course, we are monitoring the needs of the customers and the markets. And if we see the demand there, then in the future, we can easily do off-the-shelf Aquila TDA configurations as well. And I think that was a great bridge to configurations. You see one configuration listed on the left side. This is available today. This is the highest performance configuration possible, having 8 A72 cores, having 32 gigabytes of RAM, featuring 128 gigabytes of flash memory and integrating Wi-Fi 7 and Bluetooth 5.3, and all the accelerators you would expect, including the NPUs, the ISP. There is a specific one called Depth and Motion Processing Accelerator. So this is the full-featured product with full industrial temperature range support, and that's available today. If you look to the middle and the right of the slide, there are a lot of configurations which are called concepts. So these are the ones which we mapped out to be created in the future. But we are also looking for your feedback, for customer feedback, for market feedback. And along the feedback coming in, we are moving on with deciding on the exact specifics of the configurations. However, we also have the customization framework, which you mentioned before. And so on the bottom of the slide, you see most of the key options this product offers in terms of configurability. So as said before, we can assemble an AM69 chip, we can assemble a TDA4 chip offering functional safety. Depending on which one we choose, there is different number of Cortex R5 cores being available. We can assemble chip variants with 3D GPU or without, or AI accelerator or without. We can customize the memory capacity between 4 gigabytes and 32 gigabytes. Flash ranges between 32 gigabytes and 256 gigabytes, getting to even more in the future. And in terms of temperature range, we offer the full industrial temperature range, and we also offer an extended commercial temperature range with minus 25 degrees Celsius to plus 85 degrees Celsius, and with or without wireless. Probably the simple takeaway from here is that if you need a configuration which we do not have today, and you know your specific need, just please reach out to us. Because we can realize that, we are happy to realize that, and we are happy and willing to continue building out this scalable portfolio of not only the system of modules, but of the configurations for each and every system of module we are talking about. We were really hardware oriented here, and we would like to talk a lot about software as well, but we are a little bit limited on time, so we will cover it on this slide. This is all about Torizon. So what is Torizon? A suite for easily developing, managing, and securing your Linux devices. On the right side, there is this graphics. So you see the hardware layer on the bottom. This hardware layer can be our system of modules, but it can also be non-Toradex hardware. There are concrete running examples of third-party products being supported with our Torizon offering. So above the hardware, the first layer is our operating system, which is called Torizon OS. This is a Linux distribution, which is leveraging the same Yocto BSP layers we are also providing to you for all of our products. Torizon OS is also featuring containerization via Docker, but there is also a variant available without the containers. This is a very scalable operating system meant to give you production-ready software without the hassle of needing to configure and build and test and deploy. This also offers an easy migration path from Windows to Linux, because from a developer perspective, there is first-class Windows host machine support, so you can keep developing on your Windows machine, keep your Microsoft experience, but tap into the Linux ecosystem. We have integration with VS Code. For Torizon OS, we also have a graphical user interface-based solution for doing simple changes to the operating system. But of course, if you want to go all in and you would like to get the sources and reconfigure things and build and test for yourself, that's absolutely possible too. But again, what we try to do here take out the hassle, simplify this, and provide you a production-ready path to scale up. So the recommended way is actually using the operating system as is and leveraging all the testing and all the compliance which is baked in there. On the top of the stack, it's Torizon Cloud. So that's our cloud offering, providing over-the-air update capabilities, remote access and control for the devices you have in the field, fleet management, so being able to deal with masses of devices at once, and many, many more. This is continuously being developed. It's a rapidly evolving product and field. Many of our customers are interested. We see great traction. And this is one where you can truly influence the product roadmap and see how and what you will need in the future. And it's just another shout out. Please give us feedback. Let us know about what works for you, what does not work, or what would you like to see different there. Maybe going a little bit back and connecting this to the AI machine learning topics we've been talking about. So in Torizon, there is built-in support for updating your models in the field. You can reconfigure, you can optimize, and just take care of the deployment via single clicks on the mouse. There is a secure and reliable update mechanism. You can monitor your devices, so you see the resource consumption, you see the accuracy. On the inferencing, you can catch failure modes, you can predict device failures. And I still remember the times, again, in a different company, having several hundreds of devices deployed in a country, and then learning about malfunctions, delayed, and then needing to dispatch service groups who, in best case, would have returned by the end of the day, but sometimes not. So this is a very, very nice enablement there. And I need to mention, it's a very important part, the compliance with the cybersecurity regulations. But we are only scratching the surface here of what we can offer. All of this allows you to focus on our application and not on all the underlying layers, be it Linux or be it our hardware. Torizon is built with security and safety in mind, so provides you easy access to secure boot capability, to encryption, trusted execution environment, firmware TPM, and etc. An interesting capability here is that if you use Torizon and you have other components in your system which has and requires firmware to function, like microcontrollers, you are also able to deliver updates to those devices with the update solution Torizon is providing you with. And the whole update mechanism and the solution is implemented with automotive-grade security, which helps with the emerging cyber security regulations, with the EU Cyber Resilience Act being one of them, which is a very important one, and which is, we see it's one of the most interesting topics currently for our customers. There is a lot of feedback discussions ongoing, and if you are not yet familiar, and if your products are being sold in the EU or Europe in general, we would encourage you to have a look and get in touch and see how we can help you out there. This slide is about the Aquila hardware ecosystem. So I showed you before carrier boards and system of modules. We have the Aquila development board, we have the Clover, we have off-the-shelf ready-to-use thermal solutions, an active heatsink with a built-in fan. We have displays with PPDSI interface, different sizes, 10.1 inches, 7 inches. We have an LVDS display. We have a camera which is working off the shelf with the product, so just enabling you to do the evaluation and development of various vision applications. And I would like to specifically mention this connector, which we talked about before, so this 400 pins connector from Semtech. This is a state-of-the-art high-performance connector which has, in terms of signal integrity, headroom for up to PCI Express Gen 4, Gen 5. So excellent also for harshness, shock and vibration resistance. And why we are also offering this to you, and why is this in our web shop? So we have a very good collaboration with Semtech. We have good pricing for this connector with the potential and the growth we see on this family. And we would like to give this price advantage back to you as well. So if you go to our website, if you go to our web shop, you will find this connector passing you the price we have. And why this is important, because if you go on online distributors and you try searching for this connector, you will see pricing, single unit pricing, which can be factors multiple times more expensive than what we are offering. So please keep that in mind, and if you ever consider building your own carrier board, make sure you use this opportunity and you get a connector from us so you can benefit from the pricing we have there. The next slide is a very interesting one. This is the Aquila Roadmap. So we covered today the Aquila AM69. Samples are available. You can get them right now, orderable in our web shop. Volume production is coming at the end of this quarter, Q3 2025. We also touched the Aquila AM9 we are introducing the samples in the next quarter and going into mass production right the quarter after. The Aquila development board, the big development board that's available. Clover is also sampling available with Clover mass production scheduled for the end of this quarter. You also see the Aquila Roadmap here in a graphical form. So the two green bars on the left are the products, the Aquila AM69 and the Aquila AM9, which we already mentioned before. And then there are also some red bars here where the names of the products are not yet visible. We have very clear ideas there. We are talking to our favorite system-on-chip vendors, and we are talking to new candidates to be our favorites in the future. Hopefully they will be your favorites too if we go there. But at this moment, unfortunately, we can't share more details here. But instead, we can ask you to do something. So if you feel that the Aquila family is interesting, if you feel that it is resonating with what you need in the form of a system or module, and if you have any specific need or ask, be it a system or module based on a specific chip, or more approaching from functionalities, you need this and that performance for this application, please get in touch with us. This can be us on the product side direct, or you can go via the sales people you know, or the channels you have already. The most important part is just please let us know, because this enables us to develop the products which you can use and you can benefit from in the future. And on this slide, if you are interested, if you would like to give this a try, so all of this is available. The SOM, the carrier boards, the displays, the accessories. You can use basically the QR code here to get started, or you can visit our website and you find all the products there in the web shop, and on the product pages you get all the information. I would like to also point out our developer website, developer.toradex.com, where you will find a lot of technical articles, a lot of clarifications, useful and important material. One of the things which is differentiating us from most of our competitors is actually the breadth, the completeness, and the quality of this documentation. This gets as far as once in the past, I remember one of the system-on-chip vendor candidates we were talking to told to us that your developer website is our North Star for our people internally when we try to tell them what kind of documentation we should provide to our customers. And that was also covering the experience. So really worth checking out. We also have a vibrant community at community.toradex.com. And most importantly, just repeating myself one last time, if you have anything, if you have feedback, product feedback, unaddressed needs, improvement ideas, please reach out and let us know.
Very good, Simon. Thanks a lot for all of the good information. And with that, we go to the Q&A. We're almost at the end. Thanks for those that are still sticking with us here. I do see questions in the chat. So first one here is, I need a specific configuration, which I did not see before. What should I do? I'm assuming this is in, with regards to the Aquila AM69 configurations. So Simon already answered. We can customize the Aquila AM69 for you. And even if you didn't see the configuration option that you wanted there, again, here in the end, Simon also mentions that you can always reach out to our product team, to your sales representative, or just on our website, and also give product feedback. Next one, sorry, maybe I missed it in the talk, but do you provide comparisons of inference time benchmarks for AI models for some GPU model? Okay, so we do offer inference benchmarks for our products. We do have one product, the Aquila AM68 Quad Max, that runs inference on the GPU because it doesn't have an NPU, but most of our other recommended AI products have an NPU. We do have benchmarks publicly available, so you will find some on toradex.com. Under the applications menu, there is an AI landing page, and in there you will find some useful benchmarks with inference times from our products, and also on our developer documentation, as Simon mentioned, there are some very cool tables there, and there we have some stuff on GPU as well.
Maybe if you, if you have any specific need, like a concrete product which you would like to see compared, or just get an indication on, there is a lot of knowledge in our teams. So I would also recommend, if you did not find what you are specifically looking for, just please reach out, let us know about the need there. And we have field application engineers, we have people who are able to access hardware and run benchmarks, and we are more than happy to have that discussion and talk about what you need and how can we help.
Absolutely. I direct the next one to you, Simon. So does this product, and here I assume the Aquila AM69, support secure boots?
Absolutely, yes. That's an integral part of our offering. Covered it on the Torizon offering side as well. It's also a requirement for us for the future to select system on chips which incorporate the necessary features to implement secure boot. And with Torizon, you should have an easy path to actually leveraging this capability.
Very good. Just came in some other questions too. So will you launch SMARC with the AM69? This one I leave to you also, Simon.
Yeah, so this was an initial consideration we had. In a nutshell, why we haven't done it. The Aquila AM69, you've seen it before. If you put it under some significant AI machine learning load, it can consume 25-30 watts. The theoretical peak, I think, which I'm not sure if it's truly achievable, like loading up all the IPs at the same time with some synthetic load and overcoming maybe some internal bottlenecks. So may not be realistic, but theoretically we could go up to like 40-45 watts. And if we see the future potential chips which we could implement on Aquila, it's a very interesting area. You see need for sometimes even more. And if you look at SMARC, I think the standard power envelope supported by the standard is 15 watts. And I think with some workaround, maybe with risking compatibility with other SMARC offerings, you can drive that up to 25 watts. But basically, long story short, the power envelope provided on SMARC would have limited the capabilities of the AM69 to such extent that we did not feel that it would have been a reasonable move from our side to try that. And that's why we decided to craft a new form factor which was really tailored for the chips we would like to implement on it. So this means also optimized in features and cost for you, not adding more than what's needed, but also not doing less, and placing it exactly in that position which was nicely described by you, Lucas, before.
We didn't get too much in SMARC on this presentation, but I also wanted to highlight something that Simon said during the slides, which is the size of our Aquila SOM. When you include the footprint of the connector, right? Like SMARC has an edge connector. When you include the footprint of the edge connector on the PCB, it ends up being the same size as Aquila. So Aquila is able to, on the same footprint on your final PCB, pack a lot more performance than what's predictable on the SMARC specification. So that's also very interesting to see.
And I mean, it's a little bit disconnected, and it's not Aquila, but SMARC, and we already started talking about SMARC. Another very interesting thing we see, and it resonates well with the x86 to ARM migration. This is straight from our sales team, the feedback they are seeing in the market. Actually, many of the customers approaching us on SMARC are approaching us because they are having x86 solutions, and they are looking for ARM-based replacements. So this whole x86 to ARM is much broader than Aquila. It's actually happening on SMARC too, and it's also happening on some of our personal compute devices. So it's a big motion out there.
Yeah. Yeah, maybe also in more or less in line here, there's a question. Any plans from TI to support Windows 11 OS? I assume again on the Aquila AM69.
Not that I'm aware of. I'm not aware of any committed plans there. Of course, similarly to us, we feel that TI is also very open for customer and market feedback. So if any of you sees the needs there, just please let us know about the context and the exact need. And we are more than happy to take this up. And I may have hinted on this before, but when we look at that Aquila roadmap and you see this no-name red bars for now, we are definitely looking into offerings as well, where Windows 11 on ARM could be a possibility, and we could look at this as a further enabler / accelerator for the x86 to ARM migration. So very exciting topic too.
Very exciting times, yeah. Okay, we do have time for one last one, a little bit more technical one. Would your demo, I assume here the machine learning demo on the Aquila AM69, have also been able to run 8 video streams at 60 FPS? So if you remember, the demo runs 8 streams at 30 FPS. Question is if the Aquila AM69 would be able to handle 60 FPS on those streams.
So without doing a very detailed analysis on that, seeing the input capabilities, we could definitely bring in more camera streams, I think up to 12 on the AM69. If I look at the overall system load, which was, I think, averaging around 30 persons, and temperatures were not high at all, we should be able to do it. And if my memory is not mistaken, we should also be able to do it from a kind of a video processing pipeline throughput perspective. So here on the spot, I would say yes. It would be worth having a detailed look with one of our field application engineers and checking all the blocks so that there is no bottleneck preventing this from happening, but I would be pretty confident.
Cool. Okay, yeah, that's it for today. Thank you to all that stayed with us until the end here. Thanks a lot, Simon. And yep, that's it, everybody. Thanks a lot. Bye-bye.
Thank you, everyone. Take care. It was great to be here. Bye.